Hello and welcome to our first video. Here we want to give you an overview of how and where data flows can be created in the ADP. To create a new project or a new data flow, there are two possibilities. Once you can go over this red plus in the upper right corner, or you can go directly to the tab Flow Studio in the upper left corner. Clicking on the tab opens the Flow Studio, where the data flows can be created, edited, and also tested. The first time we save the data flow, we can give it a name and a description. Additionally, we can assign a category to it or create a new one if there's no suitable one yet. We will use the category testing in our case. At last, we can choose for whom the data flow should be accessible. With Create, the settings will be saved. A data flow always consists of several modules. These modules can be found in the so-called module library. The library divides the modules into three categories: input, output, and analytics. The input modules can be used to access different data sources. As you can see here, there are quite a few. For example, we can address different PLCs, read out files, or integrate OPC UA interfaces. Depending on the application, the appropriate module can be selected. We take a data generator as an example, which generates randomized data for us. Beside the input modules, there are the output modules, which are used for the desired target system. Also here, there are many different possibilities. We use in our example 2 times the MQTT pub client, over which we can publish our data to a MQTT broker. Between input and output, the data can be processed. For this, we have the analytic module section. Again, there's a whole range of different modules. In our example, we take the split module and 2 times the properties mapper. To create a data flow, we connect the modules by drag and drop. The green markers shows us which modules can be connected to each other. To configure the modules, hover over them and use the gear to open the settings. Each module can be given a name. In the case of the data generator, you can specify whether the data should come with or without a delay at the beginning. You can also define the interval at which data should be generated. We set the interval here to 1 second. Furthermore, you can define how the data to be generated should look like. We will make it as easy for ourselves in this case and take an example here. In this case, mesh and data is generated, once the temperature and once the pressure. Additionally, we would like to get a timestamp. Now we can still make settings for the individual values, such as value ranges, in the data rules section. We say here that the name should be a unique ID. The rest we leave as it is. But we additionally specify that the output should come ordered. That means always the same order of the objects. So ID 1, 2, 3. In total, there should be 10 unique sample objects. With this, we have finished configuring the module and can go to the next one. The split module forwards messages based on conditions. We can define these conditions in the condition groups. In our example, we want to receive the data structure at one output when the pressure value goes above 500, and the other time when the temperature value is above 50. Accordingly, we create 2 groups of conditions. We start with the pressure. Here, we specify to which value of the object the condition must apply. In our case, the pressure value. And we want the condition greater than 500 to be set to true. Now we do the same for the temperature. The only value that differs here is the limit, which we set to 50. Let's move on to our property mapper, which, as the name suggests, allows us to change the properties and thus the format of the data objects. In our example, we want to add a property alarm to each of our existing data objects. We do this for both the temperature and the pressure. Finally, we publish this data to the MQTT broker. There are also a few things to configure here. For example, the topic, the MQTT broker URL, the MQTT port, and security settings. These settings depend on the broker which will be used. This may also include credentials for the broker. If you use multiple broker modules, as in our case, you would have to re-enter the credentials each time. To avoid this, ADP Cloud offers the credential management. This means that you can create the credentials once. You can access the corresponding page via the tab Name and then via Credentials. The entered data can be used again and again in the modules. I've created the credentials before, and now we can select them here in the module. Each module comes with documentation explaining the functionality and input fields of the module. We will go into this in more detail in a separate video. Once the data flow has been created to the point where you can test it, you can do it using the debug button here on the right. Here you have the option to either connect to an active node or to the sandbox. The sandbox is an ADP Edge node hosted by Balluff. We will use that in our case and connect to that. That was now successful, and by switching to debug, we can now start the debug mode. Before we do that, we can activate the debug mode for each module individually. Only if this mode is active, the output message are displayed in the debug window. The whole thing works here in the upper left corner if you hover over the module and activate the little bug. If you start the test session now, we can see the data structure here on the right and see if the data flow works as expected. If you are satisfied, you can deploy the data flow to active ADP nodes. To do this, click on the tab up here, then Manage Deployments, and now you can select which ADP node you want the data flow to run on. To do this, we select an active ADP node and click Deploy. Now our flow will run on the ADP node until we actively stop it again.